Hello students, welcome to the statistics class. So in today's class we shall look at the final concept of the chapter analysis of univariate data, that is kurtosis. So till now we have studied three measures, that is measures of central tendency, measures of position, measures of dispersion and measures of skewness. So measures of central tendency and position, they generate a central number around which the entire data is revolving. Measures of central tendency. Measures of positions gives you certain positions in the data. Dispersion, particularly standard deviation, validates or checks the reliability of the average, particularly arithmetic mean. Okay, whether to rely on the mean or not. Okay, now apart from this, if we want to check the structure of the distribution, that is the distribution of the frequencies across the all the entire data set, then we go for the measures of skewness. So if the data is perfect, that is if it has identical mean, median and mode values, or if the quartiles, the positions are equidistant from each other, or if we draw the structure, if we draw the distribution on a graph paper, it resembles a bell shaped curve, then we say that such a distribution is symmetric distribution. But in reality, it is difficult to obtain such distributions. Most of the distributions are not symmetric. Okay, so there will be some kind of asymmetry in them, so that asymmetry is called as skewness. So in that again we studied two types of skewness: positive skewness and negative skewness. So in positive skewness, we see that mean is the greatest value, median is lesser than mean, and mode is lesser than median and mean. In negatively skewed distribution, we see that mean is the least value, median is greater than mean, mode is the highest value, greater than median and mean. Okay. Now the last measure for a univariate data is to see how concentrated are the values of a given data. So central tendency generates a single central number. Dispersion validates that central tendency, or dispersion checks the variability between the among the values in a given data. Skewness refers to the symmetry or asymmetric property of the distribution. So at last we have kurtosis. So here the last characteristic that we need here is kurtosis. So now if you draw a distribution, they might be of the curve might be of three types here. One is the first curve. Observe the curve here. It is the most flat curve here. So that is called as a platykurtic curve. We shall discuss that later. Next curve, the second curve is, it is neither too flat nor too peaked. It is in between them. The third curve is the too peaked curve. The height of the curve is greater than the second one and first curve. Okay. Now here all the three curves are symmetrical about mean and also have the same variation, but the shape and peakedness of the curves are different. The study of peakedness of the frequency curve is called kurtosis. Now here a curve is here is such that it rises and peaks till a point, and from there again it starts decreasing. Here also it is the same, it rises and reaches its peak till a point, and again it decreases in the same amount that it increased here. Okay, similarly the third curve also, it starts increasing, peaks at a certain point, and then again it starts falling at the same rate that it increased. Okay, so this shows that all these three curves, that is the distribution of these three curves, are symmetric. That is, all of them might have same mean, median, and mode values, and the variation among the values might also be same. That is, the mean and standard deviation of all the three distributions are same. There is no skewness at all. The three distributions are completely symmetric. Okay, but we observe that the peakedness of the curve, the shape of the curve changes here. Okay, so the studying of this peakedness of curve is called as kurtosis. Okay, so in other words, kurtosis means peakedness in the region of mode of a frequency curve. So mode of a distribution means where do you mark a mode in the given distribution? Wherever there is the highest concentration of values, whichever variable value with the highest frequency will be called as a mode. That means maximum concentration of the frequencies at that particular point. Okay, so kurtosis means studying the concentration of the mode value in the given distribution, or peakedness in the region of mode of a frequency curve. Okay, so types of kurtosis. So in the above diagram, that is here, okay, the curve which is neither flat nor peaked is called as a normal curve. Okay, so this second curve here, okay, it is neither too flat nor too peaked. Okay, so it is called as a normal curve or mesocurtic. So mesocurtic curve, its value is beta 2 is equal to 3. So initially while studying moments, we had studied about beta 1 and beta 2. Beta 1 refers to skewness and beta 2 refers to kurtosis. Okay, so and is taken as a standard to measure kurtosis. So if this is the curve of a distribution, then we say that it's a perfect distribution, a normal distribution. So this is the standard used. This is a yardstick which with which we measure the distribution. Okay. Suppose if it is too peaked, then we say it as leptokurtic. Suppose if it is too flat, then we say it is platykurtic. If it is neither peaked nor flat, then we say it is a normal distribution or a normal curve or a mesocurtic curve. Okay. The curve which is more peaked than normal curve is called as leptokurtic. So this one is called as the leptokurtic. It is too peaked than the two other curves, and the curve which is less peaked than the normal curve is known as platykurtic curve. That is the third one. This one, first curve. This is too flat. It is called as a platykurtic curve. Okay. So these are the three types of kurtosis. Normal curve, that is a mesocurtic, two peaked curve, that is a leptokurtic curve, and a two flat curve, that is platykurtic curve. Okay, the measures of kurtosis based on movements. So here we are going to measure the kurtosis depending upon the movements. Okay, so Carl Pearson gave the coefficient beta 2 or the derivative or its derivative as the measures of kurtosis. They are as follows. So we have derived four measures. We discussed about them: mu1, mu2, mu3 and mu4. So mu1 is 0, that is with respect to mean. Mu2 is your variance formula. Mu3 refers to skewness, and mu4 helps in finding the kurtosis coefficient. So beta 2 is equal to mu4 divided by mu2 square, where mu4 is the fourth central movement and mu2 is the second central movement. Also its derivative gamma 2 is nothing but beta 2 minus 3. Okay, so for a mesocurtic distribution, this beta 2 value will be is equal to 3. That is, for this curve, this beta 2 value is equal to 3. Suppose if they ask you, if beta 2 is equal to 3, then what is the type of kurtosis? Then you should write mesocurtic. Okay, similarly for a leptokurtic curve, this beta 2 value will be definitely greater than 3. So if the distribution is a leptokurtic distribution, then its beta 2 value will be definitely greater than 3 and gamma 2 will be greater than 0. Here gamma 2 will be is equal to 0. So suppose if you are calculating kurtosis for distribution and If you obtain the answers as 3 and 0, then it's a mesokurtic distribution. If you obtain the answers more than 3 and gamma 2 more than 0, then that distribution will be a leptokurtic distribution. Similarly, for a platykurtic distribution, the beta value will be less than 3 and the gamma 2 value will be definitely lesser than 0, that it might be a negative value. Okay. So these are the conditions for a mesokurtic, leptokurtic and a platykurtic distribution. Okay. So now let us look at some examples. So the first four central moments of a distribution are 0, 2.5, 0.7 and 18.75. Test the skewness and kurtosis of the distribution. So they have given you the first four central moments here. This 0 is mu1 is equal to 0, mu2 is equal to 2.5, mu3 is equal to 0.7 and mu4 is equal to 18.75. So we have to test the skewness and kurtosis of the distribution. That is, we have to find the skewness and kurtosis of the distribution. So the skewness value according to the moments is given by beta 1 is equal to mu 3 square divided by mu 2 cube, that is 0.7 square divided by 2.5 cube. So if you solve it, you will get the answer 0.31. Okay, so here the distribution skewness value is 0.031. Okay, which is a positive number. Hence, the distribution is slightly positively skewed. So this distribution for which they have given this moments, it is a positively skewed distribution. Next, let us look at the kurtosis value here. So we have the kurtosis value as beta 2 is equal to mu 4 divided by mu 2 square. So mu 4 here is 18.75 and mu 2 value is 2.5. So mu 4 18.75 divided by 2.5 square, that is 18.75 divided by 6.25, which is exactly equal to 3. Okay, so as the beta 2 value is exactly is equal to 3, therefore the distribution is a mesokurtic distribution or a normal distribution. Yes, let us look at the next problem here. So if mu1 is equal to 0, mu2 is equal to 16, mu3, this should have not been given here. Anyways, it's just mu3 is equal to minus 36 and mu4 is equal to 120. Then comment on the skewness and kurtosis of the distribution. So they have given us four central moments here. Mu1 is equal to 0, mu2 is equal to 16, mu3 is equal to minus 36 and mu4 is equal to 120. So we have to find both the skewness and kurtosis value here. Now since the mu3 is a negative value, we can't use the beta 1 formula here, because the beta 1 formula is mu3 square divided by mu2 cube. Now what happens is, if we square this 36, the negative sign will be gone. But since the distribution can also be negatively skewed, if the negative negative sign vanishes here, the result will drastically change from negative to positive skewed, which is an error. Hence, instead of taking the beta 1, we take the gamma 1 here. So gamma 1 is nothing but root of beta 1. So root of mu 3 square divided by mu 2 cube. So if you take out if you cancel the root and the square root here, so it will be mu 3 divided by sigma cube. So mu 2 is nothing but your variance value. So instead of say sigma square, they have taken the sigma cube. So if variance is 16, then standard deviation, that is the sigma square is variance and sigma means standard deviation. So if sigma square is 16, then sigma will be 4 and they have considered it here as a sigma. So 4 cube, so minus 36 divided by 4 cube, which is minus 36 divided by 64, which in turn is resulting in minus 0.5625. Therefore, the distribution is negatively skewed. Since the answer is in a negative number, the distribution is negatively skewed. Okay. So if you have the skewness as a negative number, the third central moment as a negative number, so you can go for the gamma formula instead of the direct beta 1 formula. Okay. And lastly, for a kurtosis, we need to calculate beta 2. And the beta 2 value is given by mu 4 divided by mu 2 square, which is 120 divided by 16 square. So, which is 0.469. So, this means it is lesser than 3. So, if beta 2 value is lesser than 3, that means the distribution is a platykurtic distribution. Okay. So, this was the last concept, kurtosis, pertaining to the analysis of univariate data. So, we have studied the 4 important characteristics of a univariate data. That is, first one is central tendency, which gives us a central number, a number around which all the values of the data are concentrated or revolving. The second measure of central tendency, so the second measure is dispersion. So dispersion checks the variability of the given distribution or data, and it also tells us the reliability of the central tendency obtained from that data. So almost central tendency does the 80% of the work. That is, it gives you the single number. The 10% of the work is done by standard deviation. It checks the reliability of the central tendency, and 5% of the work is done by skewness. That is to check whether the distribution is symmetric or asymmetric. And the last one is kurtosis. So in kurtosis, we try to find the concentration of the values around the mode. Okay. So this is about your concept analysis of univariate data.